Okay, so we have already graphed exponential functions. And now we're going to take a look at graphing logs, which is obviously going to be different, but also you might be thinking in your head, possibly related in some way. Because exponentials and logarithms are inverses of each other, right? So like most likely their graphs are going to be related. So we're going to graph the function. We're going to do the same thing, domain, range, and asymptote that we did with exponential functions. And we're going to start with some basic ones today. Tomorrow is the day when we reintroduce a, h, and k and shift things around. So we're going to do y equals log base 2 of x. All right, well, you guys have never graphed a log before. What do you think you might start with? A chart, a table of values. Okay. Inverse is an option. I can talk about that too. Okay, what things do you want to put into that table of values? -1, 0, 1. Okay, let's see what happens. Okay, now I'm going to do some like side work over here. When x is -1, y equals the log base 2 of -1, right? And we, right now, don't know how to do base 2 in our calculators. And this is good because I want you to try to think more about logs as what they are than just letting my calculator do it for me. Because then you never really get what a log is, right? You just let the calculator do all this stuff. Okay. So in my head, I'm thinking, what is my base? 2. And the answer to the log is the exponent. So I'm wondering, what's the exponent I need for 2? In this case, we could say it's the y value, right? The thing on the other side. And it has to equal -1. Yeah, can it? Can we raise 2 to something and get -1? No. Well, that was like we had already graphed the exponential equation or exponential function back in section 6.1. And that's the whole idea of that asymptote at the or at the x-axis, right? That no matter what kind of exponent I put, no matter how negative I make it, negatives don't make things negative and exponents, they flip. They make it a fraction. So I'm always going to have something that's positive. It's always going to be greater than 0. So your calculator would say error. I was going to put an X there, but I didn't want to confuse people by thinking it was an X. So I'll just put error. Undefined, yeah, that would be fine. Sure, if you want to write undefined UND. Yeah, something like that. You're just not going to get a graph over there. Okay. So we could probably say that for all negative numbers now, right? Okay, so then let's try y equals log base 2 of 0. Thinking in my head, that's 2 to the y equals 0. Same problem, right? This is the whole thing. If I put in a negative and I flip the 2, then I'm going to have 1 over something, which is a little bit more. So I still have an error. Oh, man. Okay, let's see if we can get one for 1. Y equals log base 2 of 1. Let's see, that's 2 to the y equals 1. Y is 0. So we can do this one.
You can't do the rest of it. That's weird.
Well, we can't do them if they're 0, and we can't do them if they are negative. But could we do anything in between 0 and 1? Oh, 1/2. That's an interesting one to try. Let me squeeze that buddy in there, right there. Okay. Squeeze it in there. 1/2. Okay, so then I'm thinking about, I'm going to run out of room over here. Y equals log base 2 of 1/2. So that's 2 to the y equals 1/2, and y equals -1. Right? Because if you raise 2 to -1, you flip it and it becomes 1/2. Can anybody give me another example of a fraction you would be able to evaluate? 1/4 would be -2. 1/8 would be -1. 3.
1/16.
1/16 would be -4. So like those numbers are getting really, really close to 0 for x, but then the number is dropping, right? And so we're going to see that in our graph in a little bit. Okay, so I got 1. Do you think there are other numbers above 1 that work?
2.
Yeah, 2. Actually, this one is one that I'm going to encourage you guys not always to put 2 on there, but whatever the base of your log is, put that in your table. Because we're going to write, this should be a y, it looks like an x, I'm sorry. Y equals log base 2 of 2. And you're thinking in your head, 2 to the y equals 2, which is 1. Now, that won't always work if I change my base 3, but if I was doing a log base 3, then maybe I would put in 3, because then the answer is 1. So really kind of understanding the pattern and how logs work is going to make making our table a lot easier. And if you want to do like those 2, or if you want to have 3 values, okay, I would always put in 1. I would put in b, which is your base, and I would put in 1 over b. Okay. Now maybe say b equals base. That's kind of like, you know, like we used to always just for exponentials, we put in -1, 0, and 1, and that we got 3 easy answers, right? If you put in 1 over b, 1, and b for x, you'll get out 3 easy answers. It'll be -1, 0, 1 every time. Okay, does anybody have any questions about how I built the table? Okay, let's graph it. Well, at 1/2 I'm at -1. At 1 I was at 0, and at 2 I'm at 1. And we know for a fact that we can't do the log of 0, or we can't do the log of any negatives. And you guys kind of like, I said, what other fractions could you put in? You said like, I could put in 1/4. If it was 1/4, then I would go down 2. If it was 1/8, I would go down 3. If it was 1/16, I would go down 4. So the asymptote is at the y-axis. Yes. So you're going to get really, really close to the y-axis, and then over here, just go up. Not too fast. Just rise. You graph the logs. Okay, so let's do domain, range, and asymptote, then we'll talk about a few other things. What do you say about my domain?
X is greater than 0.
X is greater than 0. Can we put in 0? Nope. We tried. It will never work. So X is greater than 0. What would you say about your range? All real numbers. And your asymptote. X equals 0. Okay, so are you seeing some connections between the logarithms graph and the exponentials graph from earlier in the chapter?
So, no,
Okay. So, what's that? Yes. I'm going to go to my next slide, which is remember that logs and exponentials are inverses of each other. And what did inverse mean? Opposite. How do we get an inverse? Switch x and y. So in an exponential function, for like y equals 2 to the x, we would have said domain x equals all real numbers, range y's are greater than 0, and asymptote y equals 0. And then we just did the log with the same base, y equals log base 2 of x. So the domain was x greater than 0's, the range was y is equal to all real numbers, and the asymptote was x equals 0. So Elise was saying domain and range are really just kind of flip-flopped, right? Okay. The domain becomes the range because all my x's became my y's. And the range of an exponential function switched over to be my domain because all my y's became my x's. And in terms of asymptote, instead of y equals, because I switch x and y, now it's x equals. So exponentials, asymptotes are always vertical. I mean horizontal. Sorry, don't listen to me. Are always horizontal. Y equals some number. And a log's asymptote are always vertical, which would be x equals a number. And maybe I'll write up here, domain and range switched. Okay, so going back to on that last slide when I said, how would you guys like to start graphing? You know, I heard someone say the chart, so then we did the table of values. But Mason had mentioned something about the inverses. Okay, so if you were graphing or trying to graph y equals log base 2 of x, you know that its inverse is y equals 2 to the x. You could switch x and y and solve, but that's what it's going to be, right? So you could make a table of values. This one we know is going to be 1/2. We're going to get 1 and we're going to get 2. And then to make my table of values for my log, switch x and y. So I have 1/2, 1, and 2. I'll get negative 1 and 0. 0 and 1. So that's another option. You could go through the exponential function. There are some other ways to do it. So if you have students in other classes, it may depend on their teacher, like how their teacher likes to teach it. I teach it with like what we did on the first one because that's really how we approach it in pre-calculus where most of you guys are going. So I want you to feel like, oh, I've seen that before. But there are more than one ways to graph it. You could just find its inverse, evaluate the inverse, which is usually easier, and then flip-flop x and y, and you'd be back at the same thing. Okay. And just on a side note, I'm going to go back to my previous slide. Look at those, that table of values, negative 1, 1/2, 0, 1, 1, 2 for the exponential function. If I go back to my graph of my log, and I graph y equals 2 to the x, which is its inverse, So switch x and y. That's going to be negative 1, 1/2, 0, 1, 1, 2. And remember, it has a horizontal asymptote. How are those two graphs related? Reflection. Does anybody know over which line? Y equals x. Which makes sense because what do we do to make inverses? Switch x and y, so we're saying they're the same thing. Beautiful. Okay. Okay, so let's do one more, and then you'll have some time to work. I don't want to overload you with too much today because I want you to feel confident going in tomorrow with transformations. Like, okay, I'm going to do this. So let's do one with a fraction base because everybody loves fractions, and they will be sad if I left them out. Bless you.
Thank you.
Right, Izzy?
Yes.
Right, Anna? Anna's been begging for more fraction work all year long. My star student can't have enough fractions in a day. Okay, now let's try it with the table method like we did on the first one. And what were the hints that we said to put in for x? Try 1 over b, 1, and b. Okay, so our b happens to be 1/5. So if I did 1 over 1/5, that's really 5. And then put in 1 and put in b itself, which is 1/5. So these are kind of out of order. But then I can think about, okay, y equals log base 1/5 of 5. That's saying 1/5 to what exponent equals 5? And your answer is -1. We would need to flip the base, right? To make it back into a regular number, not a fraction. And then we'll do 1. Y equals log base 1/5 of 1. So we're thinking 1/5 to what exponent y equals 1? And Mason says 0, because anything raised to 0 is equal to 1. And the next one's going to be 1, because log base 1/5 of 1/5 is 1/5 to what exponent equals 1/5. If you choose 1 over b, 1, and b, you're always going to get, for these basic ones, -1, 0, 1. Because it's like, remember, it's the flip-flopped of what we did in the exponential function. Okay? So let's plot those points. Let's see, 5, -1, 1, 0, and 1/5, 1. Where's your asymptote going to be? Should still be at the y-axis, because we still can't do logs of 0, and we still can't do logs of negatives. So x equals 0, sure thing. I'm going to draw in my asymptote. And then can you kind of imagine what's going to happen on this graph? This side is going down. And on this side, we're going to get closer and closer to the asymptote. This should be a decay function, like if we graphed its inverse, y equals 1/5 to the x. So remember, decay looks something like this. So it's that reflection over the x, or the line y equals x again. I should do domain, range, and asymptote for good measure. So domain is x is greater than 0. Range is y is equal all real number. I wrote x. That's wrong. Y equals all real numbers. And asymptote? X equals 0. Okay. What do you think? Not as bad as you thought? Okay. Here's your assignment. When you're doing your graphs, I want you to do domain, range, and asymptote. And, pick out a table. It says verify 2 points, but we practice with those 3. 1 over B, 1B. Pay attention to patterns. We're going to use all this tomorrow with transformation. You're just visiting or you? Hey, Mr. Girl.
Hello.
Oh, and these are reviews. This is good to review. We're going to quiz on Tuesday.